If you're a data scientist looking for something a little bit more interesting than the Titanic dataset, I've got just the thing for you. Meet NFL Data PY, a Python wrapper that gives you access to over 400,000 rows of granular play-by-play NFL data. Every snap, every down and distance, every outcome of the 2025 season, and it's completely free. Today, I'm going to show you what's possible with this package by analyzing a real matchup, the 49ers versus the Philadelphia Eagles. We're going to calculate expected points added, we're going to visualize the efficiency metrics, and we're going to find data that the surface level statistics completely miss. This isn't just about sports betting, it's about exploring a rich data set, whether it be Pandas aggregations or building a dashboard or just having fun within sports analytics. Let's dive in. Let me talk about why this dataset's so compelling. Not only is it free and ready to use for most researchers, it's based on this nflfastR dataset, which is maintained by a community of sports scientists and includes rich and official play-by-play data from the NFL. There are over 300 calculated columns per play. You get down and distance, you get pre-snap win probability, you get expected points added. And here's the best part. One function calls the entire season. You don't need to mess around with API calls or anything. Once you have the data stored on your system, you can get to work. All right, let's get hands-on. First, you're going to want to make sure that your NFL Data PY package is installed within your Python environment. Then, you only need to write one line of code to get the entire NFL season downloaded to your computer. That's it. So let's start by importing the packages. Let's run this line. That's how easy it is. You have the entire 2024 season. I've done some more scraping and some cleaning of the data. This will just show you how many plays. So it looks like there are 446,000 plays that we loaded from the 2025 season. Outstanding. But I really want to focus in on the Philadelphia Eagles and the San Francisco 49ers. I'm zeroing in on the expected points added for every play and the success rate. You can zero in and make heat maps of fourth downs if you want, route trees, but this is what I'm going to stick for in this video. If you look here, I'm downloading the regular season's data, and I'm copying it to the data frame. I'm taking the target teams, Philadelphia and San Francisco, and then I'm creating a new data frame with all the data just for the 49ers and just for the Eagles. This way, I'll be able to match up their data to see how they compare. After we filter out all the irrelevant teams, I also want to filter the data into just pass and run. This gets rid of all the penalties and all the nonsense plays that happen throughout a game and focuses on just the plays that matter. Let's run the code. Look, now we've filtered down to 2,060 plays. It looks like we have a clear and clean data set. Here's where Pandas really shines. You can use the group by feature to allow you to filter by only the 49ers and the Philadelphia Eagles and then aggregate by play type. This will give me, for each team and each play type, an average EPA and success rate. This is really important to see because it will start to show us how each team does. This is fascinating. Let's break it down. The run games are virtually identical. Philadelphia has a .005 earned points added per rush, and the Niners unfortunately are in the negative where we lose .004 points for every rush. Both of these are hovering around 0, which is essentially the league average for rushing attacks. Not great for a playoff team. Despite all the narratives about a dominant run games, both Christian McCaffrey and Saquon Barkley have proven ineffective this year. The Niners' passing game is an entirely different tier though. San Francisco has .15 expected points added per pass, and Philadelphia has a measly 0.4 expected points added per pass. That's nearly a 4 times difference. And look at the success rate. The Niners are successful on 52% of their dropbacks versus the Eagles, which are only 43.6. That's a 9-point gap in consistency. And this is what makes EPA so powerful. It's context aware. The 5-yard gain on the 3rd and 2 is worth way more than the 5-yard gain on 3 and 15, and EPA captures that. So what? What can you now do with the NFL dataset? It is a production grade data that you can build anything out of, and it's all open source. The NFL data library is powerful, flexible, and a great way for exploring NFL analytics in Python. We just scratched the surface for this Niners-Eagles comparison, but you can quickly go ahead from the raw data to actionable insights. I put my full code in the GitHub repository linked in the description. Clone it, run it, tweak it, make it your own. If you want more tutorials on sports analytics pages, data visualizations, or machine learning in real-world datasets, hit subscribe. I'm planning a follow-up where we build a live EPA dashboard using Streamlit. Thank you for watching.